Let's dive right in and decode some of Python's most invisible and incredibly frustrating bugs. The kind that happen completely behind the scenes and make you want to pull your hair out.
This right here is a classic Python mistake that costs literally 2 hours of debugging. When I started learning Python, I didn't understand lists versus tuples, and I kept making the exact same mistake over and over again, just staring at my screen in total frustration.
Here's what I was doing. Wrong. MyList equals mylist.append 4. The problem? Append returns none, not the updated list, because it's an in-place modification. Right. MyList.append 4. This modifies the list in place, and it always works correctly.
Once you do it the right way, your code runs successfully and your list is perfectly updated. You should absolutely save this tip and definitely comment below if you've ever fallen into this trap.
Okay, so let's move to our next concept, mutability, lists versus tuples, to understand why that bug actually happens in the first place.
The absolutely crucial point here is mutability. Now, this simply means whether or not Python actually allows you to change an object, like, adding or removing elements, after you've already created it. It's a foundational concept that completely dictates how Python handles your data under the hood. So lists are mutable, meaning they dynamically resize. And because of that flexibility, they consume more memory to allow for those future mutations. Tuples, on the flip side, are strictly immutable. Once you create a tuple, its contents are completely locked down. It doesn't need extra space, so it has lower memory consumption, and as a bonus, iterating through it is actually faster.
A great way to visualize this is to think of a list as a reusable box where elements are mapped to indices. When you mutate a list, Python is really just swapping out the items inside that existing box. It modifies the contents within the exact same object structure, rather than forcing the system to generate a brand new box for every tiny little change.
Knowing that, let's jump into in-place versus assignment operations. By convention, destructive in-place methods like .append, .sort, or random.shuffle mutate the existing data structure and explicitly return none. They basically do the heavy lifting quietly in the background to save memory. Assignment operations, however, like sorted, leave the original list completely alone and hand you a brand new object. If you use an in-place method but expect a new list, well, you end up assigning none to your variable. And boom, that's the exact bug we just talked about.
And this brings us to aliasing, which is a direct and sometimes dangerous consequence of mutability. If you assign b equals a, you are not creating a copy of the list. No way. Both variables are now pointing to the exact same mutable object in memory. So, an in-place modification to b invisibly changes a as well. If you aren't paying close attention, this invisible link will easily cost you hours of debugging.
So if that sounds tricky, let's escalate to what I like to call the mutable default nightmare.
Developer Florman Manka pretty much hit the nail on the head when he bluntly said, Python mutable defaults are the source of all evil. Bringing mutable objects into your function defaults might seem like a neat shortcut, but trust me, it will inevitably cause horrible, seemingly impossible bugs that just ruin your day. Here is the sequential disaster you absolutely need to avoid. Step 1, you define a function and set a parameter default to an empty list. Step 2, you call the function, and let's say it appends an item to that list. Step 3, you call the function again, fully expecting a fresh, empty list, right? But instead, the list unexpectedly retains the data from the previous call and just keeps growing. Why? Because that default list was created only once when the function was first defined. That exact same list object is being reused and mutated every single time you call the function. Luckily, the life-saving fix is incredibly simple. You just always set your default parameter to none in the function signature. Then, you use a quick if statement to create your empty list fresh inside the function body. By doing this, you guarantee that Python generates a brand new list object every single time the function runs, cleanly avoiding the whole trap.
All right, let's wrap things up with some best practices for debugging your Python code.
To debug like an absolute pro, first off, don't panic at the massive block of red text on your screen. Just take a breath and read the error carefully. It almost always tells you the exact line where things went sideways. Use print statements generously to track your variables step by step, especially to see if a variable unexpectedly turned into none after an in-place operation. Always double-check your data types, remembering that things like input always return text, and keep a really close eye on your loop conditions so you don't freeze your entire program in an infinite loop.
So, I want to leave you with this final thought.
Are your Python lists mutating when you aren't looking? And how will you apply this mental model of in-place operations, aliasing, and mutable defaults to bulletproof your code starting today? Because mastering these behind-the-scenes concepts is exactly what separates a beginner from a pro. Thanks so much for joining me for this explainer, and happy coding.